Good morning, students. Today we will discuss about quadratic expressions and equations. It is a chapter of algebra. Yes, quadratic equations and expressions. Quadratic equations and expressions. Quadratic equations and expressions. We have already seen these in lower classes. Once again, we will recall all those. Okay, firstly we will define quadratic expression. So we will take definition of quadratic expression. Yes, what is a quadratic expression? Very simple. An expression of the form ax square plus bx plus c, where a, b, c are real or complex numbers in which a is different from 0, is called a quadratic expression in variable x. Very simple. See, I will write the definition. An expression of the form ax square plus bx plus c, where a comma b comma c are real or complex numbers, and in which a constant a is different from 0, is called a quadratic expression. In the variable x. That's all. This is the definition. Once again, what is quadratic expression? An expression of this form ax square plus bx plus c. An expression of the form ax square plus bx plus c, where a, b, c, here x is variable and a, b, c are coefficients, constants. They can be either real numbers or they can be complex numbers, in which a should not be 0. Of course, a is a real number or complex number different from 0. Is called a quadratic expression in the variable x. What is quadratic? Quadratic means a polynomial of degree 2. What is a degree of a polynomial? Highest power of the variable is known as its degree. Quadratic means it is a polynomial of second degree, degree 2. For that reason only I have written a not equal to 0. If a is 0, then this becomes linear equation. Quadratic means its degree should be 2. That means this x square must be there in the expression. For that reason, I have taken a not equal to 0. Yes, this expression is called a quadratic expression. For example, you take x square plus 3x minus 1 is a quadratic expression. 2x square plus x plus 3, it is also a quadratic expression. Simply 2x square minus 1, it is also a quadratic expression. x square term must be there in this, then only it is a quadratic expression. What about x and constant? No problem, they can be anything, they can be a zero also. So these are some examples of quadratic expressions. One more, 3x square plus 2x, this is also a quadratic expression. Yes, for this quadratic expression we have one more definition called zero. Yes, we will see this definition. Very simple. For this quadratic equation, a complex number alpha is said to be a zero of ax square plus bx plus c if a alpha square plus b alpha plus c is 0. That's all. Very simple. If a quadratic equation is given, this is a quadratic equation. A real number alpha, a complex number alpha is said to be a root, not root. For equation root, for this expression it is called a 0. This complex number alpha is said to be a 0 of this expression if a alpha square plus b alpha plus c is 0. That means if you substitute alpha in the expression, this must be equal to 0. Then this complex number is called a 0 of this expression, this quadratic expression. Equations will have roots, expressions will have zeros, they are called zeros. For example, you take an example. So I will take x square minus 3x plus 2. Clearly it is a quadratic expression. For this quadratic equation, 1 is a 0 of this. 1 is a 0 of this, because if you put 1 in this, 1 square is 1, 3 into 1 is 3 plus 2, see, plus 3 minus 3 is 0. That is, this complex number is satisfying this. A alpha square plus b alpha plus c is what? 0. Therefore, here 1 is called a 0 of this quadratic expression. Yes. After quadratic expression, now we will see quadratic equation. Quadratic equation. Yes, what is a quadratic equation? Almost same definition. There expression, here equation. Quadratic equation, an equation of the form ax square plus bx plus c equal to 0 is called a quadratic equation in variable x. Same definition, where a comma b comma c can be either real numbers or complex numbers, in which a not equal to 0. That's all. So I will write the definition here. Quadratic equation. What is the definition? An equation of the form. An equation of the form. An equation of the form ax square plus bx plus c is equal to 0, where a comma b comma c are real or complex numbers. Real or complex numbers in which a is not equals to 0. A is different from 0 is called is called a quadratic equation. Is called a quadratic equation in the variable x. That's all. Yes, what is a quadratic? Again, quadratic means a polynomial of second degree. Quadratic always indicates second degree. So here I said an equation. Previously it was expression. Now this is equation. That is only the difference. Remaining concept property same. An equation of the form ax square plus bx plus c is equal to 0, where a, b, c, these constants, these coefficients, they can be real numbers or complex numbers. Again, a not equals to 0. This equation is called a quadratic equation in the variable x. In this equation, x is variable. A, B, C are coefficients. They can be real or complex numbers, but a should not be 0. That means A, B, C are real or complex numbers in which a is different from 0. Why a is different from 0? Already seen in the quadratic expression. If a is 0, it will not be a quadratic. But we are defining a quadratic equation. Therefore, a must be there. Then only x square will be present in the equation. It will be an equation of degree 2, that is quadratic. Yes, for example, x square minus 3x plus 2 is equal to 0. This is a quadratic equation. And 2x square minus root 3x plus 1 equal to 0. It is a quadratic equation, etc. In this we have one more definition. Root. For quadratic expressions we have zeros. For quadratic equations, roots. Almost same definition. See now. A complex number alpha is said to be a root of the quadratic equation ax square plus bx plus c equal to 0 if a alpha square plus b alpha plus c is equal to 0. Same definition. There it was expression, therefore there we call zeros. Here it is an equation. For equation we call same number, same complex number as a root. Yes, a complex number alpha is said to be a root of this equation if it satisfies the equation a alpha square plus b alpha plus c is equal to 0. See now. For example, if I take an equation x square minus 5x plus 6 is equal to 0. For this equation, 2 is a root. For this equation, 2 is a root, because if you put alpha here, this should be satisfied. Here, if you substitute 2, 2 square is 4, 5 into 2 is 10, plus 6. What is this? Clearly 10 minus 10, 0. Therefore, the complex number or real number 2 is satisfying this. Therefore, it is called a root. Very simple. Quadratic expression, quadratic equation, everything same. That one is expression, this is equation. Same definition, everything same. Both are of second degree. For expressions, what will be there? Zeros will be there. For equation, roots. Yes. Now we will see the roots of a quadratic equation. For that we have a theorem. Please see. The roots of the roots of the quadratic equation ax square plus bx plus c is equal to 0 are roots are minus b plus or minus root over b square minus 4ac whole divided by 2a. We know this, we have seen many times in lower classes. These are the roots. So once we will see its proof, Nana. We will see its proof. So here a quadratic equation is given. We have to show that we have to find the roots of that equation and to show these are those roots. So we have to find the roots, no? Therefore I will suppose let alpha be a root. Let alpha be a root of given quadratic equation ax square plus bx plus c is equal to 0. Therefore, just now we have seen a complex number alpha is said to be a root if it satisfies this a alpha square plus b alpha plus c equal to 0. This is by the definition of a root. So in this theorem what we are finding? We are finding the roots. So we have taken alpha as a root. That means we have to find alpha value. From this we need to separate alpha because roots are to be found. We have taken alpha as a root. How to separate alpha? Here alpha square is there, here alpha is there. We cannot separate it. So for that what I do? I multiply both sides by 4a. A alpha square plus b alpha plus c is equal to here also multiplying with the same. So let us multiply. What is this now? 4a square alpha square. Then 4ab into alpha plus 4ac. Right side 0 into something 0. What is our intention? Our intention is to find the roots. What is the root now? We have taken alpha as a root. Therefore, we need to separate alpha. We have to find alpha. Let us see. Here 4a square alpha square can be written as 2a alpha whole square. And I am writing this term as 2 into 2a alpha into beta. See carefully. 2 into 2, 4. A is there, B is there, alpha is there. So I wrote this term like this. Now it is of the form a square plus 2ab. If b square is there, you can write it as perfect square, but b square is not there. Therefore, adding and subtracting b square. Now the first three terms, a square plus 2ab plus b square becomes a plus b whole square. Write remaining two terms on right side. B square becomes plus and 4ac becomes minus. Whole square is there, no? Therefore, taking square root. Here I will get plus or minus root over. For every number there will be 2 square roots. We have to find alpha. So to separate alpha, no? So 2a alpha equal to, you write b also on the right side, it becomes minus b square minus 4ac. So this implies alpha is equal to, here 2a is multiplying. If you write on the right side, it divides. Minus b plus or minus root over b square minus 4ac whole divided by 2a. So by taking plus, you will get one root. By taking minus, another root. For the quadratic equation, this quadratic equation is an equation of degree 2. Therefore, it can have at most 2 roots. Number of roots of an equation depends on its degree. If you take a first degree equation, there can be only one root maximum. If you take cubic equation, it can have at most 3, not more than 3. Fourth degree equation, at most 4, not more than 4, like that. So these are the roots of the quadratic equation. Ax square plus bx plus c is equal to 0. By taking plus you will get one root, by taking minus another root. Yes. Just now we have find the roots of a quadratic equation. For the quadratic equation, ax square plus bx plus c equal to 0. What are the roots? For this equation, roots are minus b plus or minus root over b square minus 4ac whole divided by 2a. Just now we have shown this, we have seen this. Now we will see some important properties. They are all important. I will take it as notes. Right. I will explain point wise. Number 1. Just now I said a quadratic equation can have at most 2 roots, not more than 2. See Nana. Ax square plus bx plus c is equal to 0 can have at most 2 roots, not more than 2. And those roots may be real or complex. Roots can be real or complex. Roots can be real or complex, but there can be only at most 2 roots, not more than 2. Yes. Next point, number 2. Yes, in the roots of this equation, this quantity b square minus 4ac is inside the root. That was quantity. So b square minus 4ac is called the discriminant. It is called discriminant of the equation ax square plus bx plus c is equal to 0. What is this? B square minus 4ac. It is known as discriminant, most important. Roots of this equation, they depend on this discriminant only, nature of the roots. If this expression is 0, then you will get only one root. If it is greater than 0, here you will get a real number. If it is less than 0, then the roots will be complex. Therefore, this is important. B square minus 4ac is called discriminant. What is this? Discriminant of the equation. It is denoted by delta or capital D. Delta or capital D. That means delta or capital D is equal to b square minus 4ac. So this is discriminant. Nature of the roots and many properties depend on this discriminant. Next, third note, third property. See Nana. So this quadratic equation will have 2 roots. What are the roots if I write separately? First root is this, whole divided by 2a. And the second root is minus b minus root over b square minus 4ac by 2a. These are the 2 roots. Now we will see their sum. For example, you suppose this root is alpha, this root is beta. What is the sum of these 2 roots? Let us see. Both are fractions at the moment, same denominator. By when you are adding these two, you are supposed to take LCM. LCM is 2a. So we will get minus b plus root over b square minus 4ac minus b minus root over b square minus 4ac. So I can cut minus root over b square minus 4ac and plus. So minus b is minus 2b divided by 2a. 2 gets cancelled. We will have what? Minus b by a. Therefore, this quadratic equation will have two roots at most, of course. Sum of the roots is what? Minus b by a. That is minus of, what is b? X coefficient by a is x square coefficient. Similarly, you can see their product. Product means you are supposed to take the product of this and this. See carefully. So this is what? This 2a divides away, of course. When you are multiplying these two fractions, you should multiply numerators and denominators. Numerators, you suppose minus b is a. This is a plus b and a minus b. A plus b into a minus b is a square. Minus b whole square means b square. Minus b square means root will be cancelled. I have applied a plus b into a minus b. In the denominator, 2a into 2a is 4a square. If you simplify this, b square minus b square minus into minus plus 4ac by 4a square. Minus b square plus b square cancelled. Also 4 and 1a, a will be cut. So what is remaining here? C by a. Therefore, this quadratic equation will have two roots. Sum of the roots is minus b by a and product of the roots is c by a. So we will add one more root. See carefully. The sum of the roots. The sum of the roots of the quadratic equation ax square plus bx plus c is equal to 0 is. What is the sum of the roots? Sum of the roots is minus b by a. Minus b by a. Oh, here a is x square coefficient and b is x coefficient. This is sum of the roots. Next is another note we will take, the product of the roots. The product of the roots. The product of the roots of the quadratic equation ax square plus bx plus c is equal to 0 is. What is the product of the roots? It is c by a. So sum of the roots and product of the roots. Okay. Also we can take the difference of the roots also useful in objective. The difference of the roots. The difference of the roots of the quadratic equation ax square plus bx plus c is equal to 0 is. Yes, we will see what is the difference of the roots. Very simple. This one is very much useful in objective. See now. For this quadratic equation ax square plus bx plus c is equal to 0. I suppose alpha, beta are the roots. So we know the sum of the roots. Sum of the roots is what? Minus b by a. And also we have seen product of the roots is c by a. Now we need difference of the roots. What is difference of the roots? Alpha minus beta. We know alpha plus beta, alpha, beta, no. A plus B is there, AB is there. You can find A minus B. For that I will consider this. Alpha minus beta, that is A minus B whole square. This is what? A plus B whole square minus 4AB. Yes. What is alpha plus beta? Minus B by A. Square is there. Therefore, we will get B square by A square. Minus 4 alpha beta. Alpha beta is C by A. Therefore, let us simplify, take LCM. LCM is A square. We will get B square. Here only A is there, no? 4AC will come. So this is alpha minus beta whole square. If I take square root, that is always there will be 2 square roots. For that only I have written mod. That means I am taking positive value among those two. This is alpha minus beta whole square. What is alpha minus beta? I have to take root, no? So root over B square minus 4AC divided by A square root is A. We are considering positive quantity, therefore this one. What is this B square minus 4AC? It is discriminant, no? Therefore you can also denote this by delta. Yes, therefore the difference of the roots of this equation is root over B square minus 4AC whole divided by mod A, which is also represented like this, root over delta by mod A. So this is another important note. Sum of the roots, product of the roots, also I wrote difference of the roots. Yes. Next, sixth property, sixth note. See Nana, for example, if alpha and beta are the roots of the quadratic equation ax square plus bx plus c is equal to 0, then this quadratic expression, if you don't take equation, it is called expression. This one is important. This expression can be expressed as x square coefficient into x minus 1 root into x minus another root. So if alpha, beta are roots of this quadratic equation, then we can express this quadratic expression as a into x minus alpha into x minus beta. Later we will explain this also while there are some theorems. At the time of theorems I will explain how it will come. Next point, number 7. So if quadratic equation is given, you can find the roots by using minus b plus or minus that formula, or simply by factorization also you can find. Reversely, if roots are given, how to write the quadratic equation? See now. This point number 7 says that the quadratic equation having roots alpha and beta is, when roots are given, how to write this? Of course we know, we have seen in lower classes. The quadratic equation is x square minus sum of the roots into x plus product of the roots is equal to 0. This is the quadratic equation having roots alpha and beta. This can be written like this also. See now, what I wrote here, x square minus alpha plus beta into x plus alpha beta. So I will simplify this, x square minus alpha x minus beta x minus alpha beta. I am factorizing, taking x common, x minus alpha, taking minus beta common, x minus alpha. Now taking x minus alpha, here we will have x and there beta. So this can be written like this also. So another form of this is very simple one. X minus alpha into x minus beta is equal to 0. So this is the writing of a quadratic equation when roots are given. Quadratic equation means generally it will have two roots. When two roots are given, to form the quadratic equation, you can apply this or this. You please see second one. There are two roots for a quadratic equation. If alpha, beta are roots, then what is the equation? X minus alpha into x minus beta, where alpha, beta are roots. This is applicable for other equations also. For example, if you want to write a cubic equation, generally it will have three roots, no? Alpha, beta, gamma. What to do? X minus alpha into x minus beta into x minus gamma equal to 0. Similarly, fourth degree equation is there. There are four roots given. We have to find the equation. What to do? Simple, same procedure. X minus alpha, x minus beta, x minus gamma, x minus delta something. Yes, this is quadratic equation when roots are given. Yes. Now we will see the nature of the roots. Listen now. Nature of the roots. Nature of the roots of the quadratic equation ax square plus bx plus c is equal to 0. So nature of the roots of this quadratic equation we will see in two different cases. First one, see carefully. What is first case? If a comma b comma c are real numbers. Real numbers. Next, second case, if ABC are rational numbers. Rational numbers. You should have clear idea about real numbers and rational numbers. 1 second. Number system begins with natural numbers. First set of numbers. All counting numbers. 1, 2, 3, etc. All counting numbers means all positive numbers. After inventing 0, one more system has introduced whole numbers, which include 0 also, 0 and all natural numbers. Next, when invented negative numbers, then one more system has come, integers, all whole numbers and also negative numbers. This is set of integers. And fractions, after getting fractions, rational numbers, another system of numbers. What is rational numbers? All the numbers of the form p by q, where p comma q can be integers, any integers in which q is not equals to 0. This is rational numbers. And irrational numbers. What is q dash? Q dash is irrational numbers. What will be there in irrational numbers? The numbers which cannot be expressed in the form p by q. the numbers which cannot be expressed in the form p by q. That means all positive square root numbers which cannot be expressed in the form p by q. If you take root 3, what is root 3? 1.732. Still it continues. Decimal, it will not end. Then it cannot be expressed in the form p by q. Such numbers are called irrational numbers. You observe here, all the natural numbers will come in whole numbers. It is a subset of this. This is a subset of this, and this is a subset of this, and this is different. Finally, a superior set has come, real numbers, which is union of rational and irrational numbers. That means rational numbers will cover all the numbers so defined in that case time. So this is real numbers. Its superior set is set of complex numbers. All the real numbers will be there in complex number. It is a subset of C, like that. So here we will discuss the nature of the roots in two different cases. One is for when ABC coefficients are real numbers and rational numbers. So here in the first case, you please see number 1. We are discussing the nature of roots of this equation only, ax square plus bx plus c. Nature of the roots depends on the discriminant. Listen now. If delta is equal to 0, see what are the roots? Roots are minus b plus or minus root over b square minus 4ac whole divided by 2a. Yes, if delta is 0, delta means this expression, this quantity is 0, square root of 0 is 0. What it becomes? Minus b by 2a only. You will get only one number. That means what number? Minus b by 2a. Again the root is a real one. But only one root will come. That means other root is also same. So therefore if delta equal to 0, then the roots are real and equal. Next, number 2. If delta is positive greater than 0. If delta is greater than 0 means, for example, you suppose this value is 4. For example, you suppose 4 means what you get? Square root of 4 means 2, minus b plus or minus 2 by this. By taking one plus sign, you will get one root. By taking minus another root, different root. They both will be real. So delta greater than 0, then the roots are real and different or distinct. Roots are real and distinct. Next, number 3. If discriminant is less than 0. Discriminant less than 0 means this value is negative number. Negative numbers means imaginary. What are imaginary numbers? Further they become complex numbers. So therefore if delta less than 0, then the roots are imaginary. Roots are imaginary. Further they are complex numbers. Further they are conjugate complex numbers. Conjugate complex numbers. For example, if delta is less than 0, for example delta, this is minus root 3. So under root of minus root 3 can be written as root 3 into root over minus 1, which is I in the complex numbers. So minus b can be any real number. So for example, this b is minus b. You suppose minus b is 1. What is there? Plus or minus. This is what? Root 3i. 2a will be there. A can be any number. For example, you suppose 1 by 2. 2 into 1 by 2. 1. These are the roots. So what are the roots? 1 plus root 3i and 1 minus root 3i. So whenever roots are occurred in complex numbers, they occur in conjugates. This is conjugate of this. This is conjugate of this. We will see these in complex numbers. For example, 1 plus I and 1 minus I. They are called conjugate complex numbers to each other. Yes. Therefore, when the first case, if ABC coefficients are real numbers, then these are the 3 cases. Next, coming to this, if ABC are rational number, here real numbers means these ABC can be either rational or irrational. Irrational means root 2, root 3, etc. But here ABC are what? Only rational, no square roots, only rational numbers. In this case, first one is again, if delta is equal to 0, delta equal to 0, in this case roots are rational and equal. Roots are rational and equal. Rational and equal. So here what is this? Root, these are 3 rational numbers. Under root of b square minus 4ac, that is 0. That means we have already seen that under root of b square minus 4ac 0 means you will have only minus b by 2a. Both root will be same, both will be same. Therefore, roots are rational and equal. Both roots will be rational. Next, number 2. If delta greater than 0 and is a perfect square, then this implies, what is this? Minus b plus or minus under root of b square minus 4ac by 2a. These are the roots now. Now this delta is positive and it is a perfect square. That means 4, 9, etc. When it is a perfect square, square root will be there for that. No root will be there now. For example, if it is 4, root 4 is what? 2. No root now. By taking plus, you will get one root minus another root. Both will be again rational numbers only. So in this case, roots are rational and distinct. Rational and distinct. Next, number 3. If delta greater than 0 and is not a perfect square, it is not a perfect square. It is not a perfect square means this value is positive, but it is not a perfect square. It is not 4, 9, etc. It is something 5, 6, 7, etc. If 5 is there, root 5. What is root 5? It is an irrational number, remains as it is only. So therefore, in this case, the roots will be irrational. Roots are irrational. Irrational and different. Irrational root means they are thirds. Here also, when discriminant is less than 0, roots are imaginary. Further, they are complex numbers. For any equation, always complex numbers occur in conjugates. Here also, whenever irrational roots will come, they also occur in conjugates. For example, a plus root b is a number. A minus root b is another irrational number, which is conjugate of that. So when irrational roots are there, they are also occur in conjugates. So roots are irrational and different. Of course, you can write here they are conjugates. Next, number 4, as usual, this one, if delta less than 0. When delta less than 0, same thing, roots will be imaginary, they will be conjugate complex numbers. If delta is less than 0, roots are imaginary. Roots are imaginary and conjugate complex numbers. Complex numbers. Yes. This is about nature of the roots of the quadratic equation ax square plus bx plus c equal to 0. Yes. So we will discuss one more theorem. Yes, in this theorem, what we discuss about the condition. See now, theorem. The condition for the roots of the quadratic equation ax square plus bx plus c equal to 0 to be in the ratio m is to n. M is to n. This concept is also very much useful in objective. Let us discuss this. We will see the proof. Yes. So what is given, we are discussing here about the condition for the roots of this equation to be in the ratio m is to n. Okay. So roots are, listen Nana, proof. The roots of ax square plus bx plus c is equal to 0 or in the ratio m is to n. So I am supposing that the roots of there will be two roots. I am supposing that I am taking that the roots are in the ratio m is to n. And I will take the roots. I have to take two roots because it is a quadratic equation and the root should be in that ratio, no? Therefore, let m alpha comma n alpha be the roots. Clearly, the roots which I have taken are in the ratio m is to n. Okay. Now I will write the sum of the roots. M alpha plus n alpha. We know for this equation what is the sum? Minus b by a. Here I will take alpha. If I take alpha common, m plus n is minus b by a. From this, alpha is equal to minus b divided by a into m plus n. So these are the roots I took. I took m alpha, n alpha. Clearly, if I cut alpha, what is the ratio of the roots? M is to n. Here, what is alpha? Alpha can be anything. It is called a parameter. If alpha is 1, what will be the ratio? M is to n. If alpha is 2, 2m is to 2n. Again m is to n. So, alpha is a parameter. When for the problems of locus and conditions, this is important. Whenever you are finding a condition, if any parameters are there, how to get the conditions? Just eliminate the parameter. For locus also same. For the problems of locus involving a parameter, there by simply eliminating parameter you will get locus. Yes, for conditions and locus problems, if there are any parameters, you simply eliminate the parameters, then you will be getting conditions and locus. So I have written what? Sum of the roots. Next I will also write product of the roots. These are the roots here, m alpha, n alpha. What is the product of the roots? C by a. We know this. So what is this? Mn into alpha square. This is C by A, equation number 2. So to get the condition, very simply, from equations 1 and 2, you eliminate the parameter. Alpha is parameter. So Mn into alpha square. What is alpha from 1? It is minus b divided by a into m plus n. This is alpha. Square is there. Is equal to c by a. This is the condition. When alpha is parameter is eliminated, that will give us the locus or condition. See, let us simplify this. Mn into square is there, no? You will get b square divided by a square into m plus n whole square is equal to c by a. I can cut one a and a. So I will arrange this as, see carefully, left side mn into b square, cross multiplication ac into m plus n. That's all. AC into m plus n whole square, of course. This is the condition. Very much useful in objective. So you can remember that condition in books. This will be given like this: m plus n whole square AC into m plus n whole square equal to b square into mn. Ratio will be given. Roots of a quadratic equation are in the ratio 2:3. That means m is 2, n is 3. Put in the condition. So therefore this is the condition. Yes. Now we have seen the condition for the roots of the equation to be in the ratio m is to n. We will collect some more information. Please see. Note number 1. Once again I will mention that. What is that? The roots of ax square plus bx plus c is equal to 0 or in the ratio m is to n. Then the condition is, what is the condition? Just now we have seen. The condition is m plus n whole square into AC is equal to b square into mn. This is the condition. Condition for the roots to be in the ratio m is to n. Next we will see another condition. Here roots are in the ratio m is to n. For example, roots of that equation. One root may be square of the other. One root may be cube of the other. You can prove those similar procedure. Here roots are in the ratio m is to n. What I did, I take roots as mn, m alpha, n alpha. If one root is square of the other, then you should take one root alpha and other root alpha square. Write sum of the roots, product of the roots, eliminate the parameter. So you do those. I will write only formulas here. Please see. First property, next second one. If one root of ax square plus bx plus c is equal to 0 is the square of the other. Square of the other. Square of the other. Then this implies, what is the condition? AC into a plus c plus bq is equal to 3abc. This is the condition. Condition for one root to be square of the other can be proved similarly. These are all important in objective. Next, see third one. If one root is nth power, if one root of this equation ax square plus bx plus c equal to 0 is the nth root of the other, then this implies, what is the condition? A power n into c whole power 1 by n plus 1. I will write here a power n into c whole power 1 by n plus 1 plus a into c power n whole power 1 by n plus 1 plus b is equal to 0. This is the condition. Yes, next number 4. See now, next fourth property or fourth root. For the equation ax square plus bx plus c is equal to 0. Generally, it will have two roots. For this equation, number 1, if one unity is a root, then a plus b plus c, or we will write in other words. For this quadratic equation, if a plus b plus c is 0, this is important one. If the sum of the coefficients is 0, if a plus b plus c is 0, then unity 1 is a root. 1 is a root of this equation, and the other root is c by a. Why c by a? So whenever a plus b plus c is 0, sum of the roots is 0, I said 1 is a root, then other root is c by a. So for this equation, we know product of the roots is c by a. Among the roots, one root is what? 1. 1 into beta, beta only. Then what is beta? C by a. Other root is c by a. Next property, number 5. See carefully, for this quadratic equation, for ax square plus bx plus c is equal to 0, if here a plus b plus c is 0, no? If a minus b plus c is 0, then minus 1 will be a root. Minus 1 is a root of this equation, and the other root is what is other root now? Minus c by a, because product of the root should be c by a. So minus c by a. Next one, number 6th point. See carefully. If one root is negative of the other, one root is negative of the other. What does it mean? If one root is 2, what is other root? Negative of this, minus 2. If one root is minus 3, other root is 3, like that. If one root is negative of the other, then the condition will be b is equal to 0. condition will be b is equal to 0. Whenever b is 0, you will get two roots with same magnitude, opposite sign. Next one, number 7. Yes, if one root is reciprocal, one root is reciprocal of the other. Reciprocal of the other. Then what is the condition? A is equal to C. In the equation ax square plus bx plus c equal to 0, if x square coefficient and constant are equal, then it will have two roots which are reciprocals to each other. Okay, these are some more properties of this quadratic expression. We will be using these in objective especially. So once again, the roots of this equation, quadratic equation, if the roots are in the ratio m is to n, then the condition is this. Similarly, if one root of this is a square of other, there will be two roots, no? One root is square of the other, then the condition is this. If one root is nth root of another root, then condition is this one. Condition for one root to be nth root of this, not nth root, nth power. Yes, if one root is nth power of other, then this is the condition. For this quadratic equation, if in this equation sum of the coefficients is 0, if the sum of the coefficients is 0, then one is a root and other root is what? C by A. If in the equation A minus B plus C is 0, then minus 1 will be always a root and other root will be minus C by A. Next, in the equation quadratic equation, if B is 0, that means if a quadratic equation has no x term, then definitely it will have two roots. One root will be the negative root of other. That is, if one root is 2, other root is minus 2, etc. And if A is equal to C in this equation, x square coefficient and constant are equal. In that case, you will get the two roots which are reciprocals to each other. So you are supposed to practice these, learn these perfectly. Then in objective it will be very simple, very useful. So these are some concepts of quadratic equations and expressions. Still there are many other concepts which we will discuss in the next video. Thank you.